Hello everyone, welcome to Finite Element Analysis Laboratory by Youni-Learning, episode 13. Today we are going to perform a very important experiment which is related to pressure vessel. Our objective is to calculate and verify circumferential and hoop stresses of a pressurized spherical pressure vessel by numerical and analytical method. We will utilize static structural module for this purpose. The specimen will be a vessel which is pressurized. We will specify some boundary conditions related to it and will perform this experiment in ANSYS Workbench. We will verify various laws and determine and discuss the theory of pressure vessel. There are two types of pressure vessels generally available in the market. The first one is the spherical pressure vessel and the other one is the spherical pressure vessel. In the present topic, we will perform the analysis on a spherical pressure vessel. The spherical pressure vessel, as the name indicates, consists of a sphere, just like this, and an opening at the top which is used for the insertion purposes. The parameters of the dimension of the spherical pressure vessel are given as follows, in which Ri is the inner side radius, R0 is the 200 mm outside radius, and cylindrical nozzle dimension, which is at the top of the spherical pressure vessel, is 30 mm inside and 50 mm outside. The nozzle length will be 70 mm. We will perform this analysis and will write its FEA results here. Now we will move on to the ANSYS Workbench software to perform this analysis. As you can see, my ANSYS Workbench window has been opened. Now kindly double click on the static structural module. It will create an analysis system as shown here. Kindly rename it to pressure vessel. Now right click on the geometry tab and select properties. We are going to model it in 2D space and will extend it into 3D. So click properties and change the analysis type from here to 3D to 2D. Now right click on the geometry tab and go to the new design modeler, which is the ANSYS built-in CAD software for creating the geometry. It will take a minute to start the design modeler. You can also model this geometry on other software such as SolidWorks or AutoCAD and import it as per your requirement. It is recommended that you model the geometry in ANSYS Workbench software and do not try to import it as frequently. Now, to model the geometry, kindly click on the XY plane and select the look at command from here. This will convert the 3D axis into a 2D space. Now go into the sketching window and select a circle command from here. Draw two circles at the origin, just like this. First circle and then the second circle. After drawing these circles, kindly dimension these circles to be according to these dimensions, in which Ri is 0.180 and R0 is 0.2. So we will place the dimension holder, general, and select this, which is Ri, which is here it is diameter, so we will convert it. It will become 0.36. Similarly, we will place dimension here. It will become 0.4 because it is diameter. Now after adding these diameters, Kindly click the out of it command. Now it is showing that the geometrical dimension would are placed at this particular distance, so we will zoom it here. Now go into draw again, select line command, and now we will select this edge of the outer circle and we'll draw a vertical line like this. Similarly, start line again from here and draw a horizontal line on the left hand side. Then again start a line in and end it vertically downward on this circle like this. Now we will modify it and use the trim command here. Remove the remaining extra part. But before doing that, we will draw a line here which start from this circle and will end at this circle. I will create a line which is extended so that the circle touch and the line touches both of these circles. Now I will go into modify and select trim command. Now trim this part, trim this part, this part and this part, and then this extended part. It will automatically cut the part that is extended extra. Now we will trim these parts and select this part. Now our part has been successfully created. We will click it here, and now we will apply dimensions, and we will place dimension between this node and this axis, which is this. Then we again place this node and this axis again here, which is h4. The value of h3 and h4 is these inner radiuses, which is 0.03 and 0.05. We will place it here 0.03 and 0.05 like this. Now the last thing that is remaining is the nozzle length, which is 70 mm, means 0.07, which is this one. So we will place a dimension holder here and name it to be 0.07 meters like this. Now we will remove the other remaining parts using trim command and select this line and this line, and we'll also remove this middle line. Now a closed loop sketch has been created. To convert this sketch into a surface, go into the concept and select surface from sketches and select this sketch and click apply and press generate button. It will convert this sketch into a surface, which is a body available in ANSYS software for defining the geometry. Now at this point our geometry has been successfully modeled. Kindly close this window from here and double click on the model tab. It will start ANSYS mechanical module in which we will specify the symmetry of the geometry, the boundary conditions, and the results that are required. Now the ANSYS mechanical module has been started. Kindly go into the geometry, simple click on it and change the behavior from 2D plane stress to axis symmetric. After doing so, go into the model tab, right click on it and go into the insert tab and select symmetry. After doing so, go into the symmetry and change the type from Cartesian to 2D axis symmetric, and change the angle from 10 degree to, let's say, 36 degree. Now create mesh by right clicking on the mesh tab. As you can see, this is the pressure vessel that we are trying to design. I will change the view from 2D to axis symmetric. Now, as you can see, at every angle a similar shape has been created and has been divided into a finite number of elements. In order to further refine this mesh, I will change the size. First I will change the units from inches to meters and will enter the value of 0.04 millimeters, and now I will again generate the mesh. Now it is showing that you have created mesh. I will further reduce this 4 times less, and now again I will generate the mesh. Now it is further smaller. Now go into the symmetric and change the angle from 36 degree to 10 degree again, and we will again generate the mesh. And as you can see, the body has been divided into a finite number of elements. Now we will assign the boundary conditions. In order to assign the boundary conditions, change the view from 3D to 2D and right click on the static structural, go to insert and select fixed support and choose this node here and click apply. Similarly, go into the static structural, right click, insert and select force and select this edge and click apply and enter a magnitude of 1 Newton. After doing so, apply the direction by simply clicking apply. If it is not changing, change it from vector to components and simply enter the force along x-axis, which is 1 Newton. Similarly like this. Now go into the solution, right click, insert deformation total, then again deformation along x, y and z, deformation directional, deformation directional, deformation directional. I will change the axis from y, x and y. I will remove this remaining and will rename it based on the definition, which is along x-axis. Similarly, I will again select this option and this will be along y-axis. If this 3D axisymmetric shape is not being shown after generating the mesh, purpose of the reason behind this is that kindly go into the workbench, go into the tools, select options and go into the appearance tab and scroll down from here and you can see this beta option. Kindly check this box and click OK and go into the mechanical module. Again it will start showing you the 3D model. Now solve this. It is solving this model. Now, as you can see, our model has been successfully solved. We will go into a 2D view and will select the total deformation. As you can see, the total deformation of against 1 Newton force is 6.9921 e raised to the power minus 11. Along x is this and along y is this. Similarly, go into the solution again and insert stress and select normal and solve the model again. And it is showing that a normal stress of 23.779 is being applied. Currently go into the isometric view and you can see that this region is under compressive, which is also 16.084. The stress magnitude at this region is also high, which is the connection point between the nozzle and the spherical pressure vessel. Our analysis has been completed. Kindly close this window and save your project by going into the file, save as, and save your model in the required directory. I am saving with my model here. Episode 13 and click enter. Similarly, create an archive file of this project by going into the file, archive, and save this archive. Thank you very much. If you have any questions, you can ask. Kindly comment below and subscribe the channel for more recent updates. Thank you very much.